Welcome to eAcademy. My name is Mr. Carlson. Today we have a geometry lesson involving, first of all, identifying corresponding angles, and then once we've identified them, we want to use their angle relationships to set up equations and solve. This is your Power Standard Skills numbers 8 and 10. So let's go ahead and get started on that. Alright, let's begin by defining corresponding angles. First of all, corresponding angles are created when a transversal, which is this segment or line running through here, crosses lines. It doesn't have to be parallel, but usually in most cases when we look at it, they will be parallel lines. And the corresponding angles would be angles that are in the same relative position to the parallel lines and the transversal. Okay, so at any intersection they're in the same location. So for instance, you'll notice these two angles here, angle AEP and angle EFR. Those two angles are both 70 degrees. Those angles are corresponding angles. They're both above the parallel lines and they're both to the left of the transversal. Now, when this happens, when a transversal runs through parallel lines, there are four pairs of corresponding angles. Here's another pair. These are both to the right of the transversal and above the parallel lines. And you can see here's the next pair and finally the fourth pair. So corresponding angles, the key to knowing that about corresponding angles that they're in the same relative position. Now, the other thing that we know about them is that if these lines are parallel to each other, corresponding angles will always be congruent or equal in measure, and that's what we're going to use in trying to solve some problems involving corresponding angles. Alright, let's take a look at a problem involving corresponding angles. Below we have a picture of two parallel lines and a transversal running through those parallel lines, and I have angle 1 and angle 2 labeled. So first of all, we know that angle 1 and angle 2 are in the same relative position, therefore they would be corresponding angles. So using that fact and using what we know about the measures of those angles in terms of those algebraic expressions, see if you can set up an equation to solve involving angles 1 and angles 2. When you're done, go ahead and turn the video back on and we'll take a look at that. Alright, here's the equation that I have, and I hope you have the same thing. We know these lines are parallel to each other, therefore 1 and 2 are corresponding, and we know corresponding angles are equal if the lines are parallel. So we're going to go ahead and solve for x and then plug it back in to find angles 1 and 2. Shouldn't be too hard. Let's go ahead and do that. I'm going to start by subtracting 9x from both sides. If I do that, I have negative 2x plus 11 is equal to negative 3. Now I got to get my constants together, so I'm going to subtract 11 from both sides. And then I'm left with negative 2x is equal to negative 14. And then remember, when we divide, we want to divide by that negative 2, not just 2. And if I do that, x is equal to 7. And once again, that's not my answer. That's just the value of x. Now I've got to plug it into either this one or this one. It doesn't matter. Okay, so let's go ahead and I'm going to plug into angle 1. So the measure of angle 1 is equal to 7 times, instead of x, I'm going to put in 7 plus 11. Well, that's 7 times 7 is 49 plus 11, which is equal to 60. Therefore, the measure of angle 1 is 60 degrees. And we also know the measure of angle 2 must be 60 degrees as well, because those two have to be equal to each other. Just to be sure, let's just go ahead and find the measure of angle 2. Negative 3 plus 9 times 7. Well, that's negative 3 plus 63, which is also equal to 60 degrees. So it checks out. Alright?